Yes, let's do that.
Open the floodgates.
2 मिनट और
वो निकालो
क्या
YouTube लाइव
यही है
2
2
मिनट
मिनट और
Classrooms. The webinars will cover topics such as psychology of learning, student engagement, assessment techniques, inquiry and simulation-based learning, etc. Bringing together experts in the field of education, we hope to bridge the gap between theory and practice of digital education. The webinars will cover topics such as... We wish to thank all participants for an overwhelming response. Before we proceed with today's program, we wish to update everyone regarding the certification criteria. We have received many requests, hence please pay attention to the certification criteria. The certification is available for all registered participants. At the end of webinar series, we will be conducting an online exam. We will be sharing the details of this later. Upon successful completion of the exam, the registered participants will be eligible for certification. Before we begin with today's proceedings, we wish to also communicate some guidelines that we should all follow for the smooth functioning of this program. We request everyone to mute their mics and videos during the webinar. Those who cannot join on Zoom are requested to view this webinar on the YouTube link provided. We understand that there is a limiting seating in the Zoom room. Hence, please follow us on YouTube. Also, please subscribe to our YouTube channel to stay updated about the upcoming webinars and events by Science Activity Center. Kindly put in your questions in the Zoom chat box or the YouTube chat box that you wish to ask the speakers. We will be monitoring both chat boxes and will communicate your questions at the end of their talk. With that, let us begin with today's program. To inaugurate today's session, we have with us Professor Bhas Bapat. Professor Bhas is a faculty in the physics department and the Dean of Academics at IISER Pune. His research interests include studying atomic collisions and molecular fragmentation. With a keen interest in teaching and learning, Professor Bhas has contributed extensively to the field of physics education. He has contributed in making education policies, conducting novel workshops for students and teachers, many manuscripts, and some interesting books for school students. I now request Professor Bhas to inaugurate today's webinar and also share some of his thoughts.
Thank you, Neeraj. It is a pleasure for me to inaugurate this session in a virtual manner, teaching the next generation, which I think is going to be a very different challenge from the past. And even as we speak, we are actually toying with some of the tools of the next generation. I hope that this program goes off to a grand start with Sir John's lecture and many more interesting contributions from different people to come. I am sure that all of you will sustain your participation in the long run, and generally hope that this program succeeds in reaching its goals. At the outset, I would like to share a few of my own thoughts about this topic. So I'll take maybe 5 minutes to do this. Is that fine, Neeraj?
Sure, please do.
Okay. Yeah. So what I would like to bring to your notice is that we are really at a cusp in our social, educational, professional lives, which has been inflicted upon us by the pandemic. It is not of our own doing, so to speak. It has been forced upon us. But this cusp is really an opportunity for us to think about how we would like to go ahead, how we would like to shape and plan our future professional dealings. All of us are teachers here, so our engagement with students is something that we hold close to our heart. And the change situation, I'm sure, has forced us all to think of how we are going to deal with this and similar situations in the future. Like at every stage of progress of mankind, of humankind, or specifically in education, we always need to look back in order to decide what we should be doing in the future. Because the past gives us an experience on which to build, to learn from our mistakes, and to improve on them as we head into the future. And this point is at this juncture in our lives, is really an ideal pause point for us to look back and see how things are going to shape. Because the digital revolution, which has touched our lives in different ways in the past, mostly in the form of mobile phone communication and availability of internet, has impacted us hugely in these last few months in our professional spheres. Even the grade 1 student now talks in terms of being able to access online content, which wasn't heard of 6 months ago. Okay. So this is a every change requires us to change gears, look at our ways of doing things, look at how we can adapt to it, how we can make the best of the situation, and so on. And in this context, what I would like to point out is that there is a lot of talk on how to deliver content. I mean, in the last few months, I must have heard this word heard this phrase being used umpteen number of times. But teaching is not just about delivery of content. I mean, delivery of content, of course, is an important part, but that's by no means the most important part. And when we talk of the digital platform, our discussions so far have, for whatever reasons, mostly dictated by circumstances, have focused on the delivery of content. But the new medium, the digital medium, has many more opportunities, many more challenges than just the content part. The digital medium has many new options available. It has made many new options available to us. It has made it possible for students to learn or engage at their own pace, which is not possible in the traditional classroom. But it also has some disadvantages. It has some shortcomings of not being able to talk person to person. The peer interaction doesn't quite have the same tactile feel as it does in a classroom. Engagement with teachers is, well, it's possible, but we are still grappling with non-physical contact. But these are challenges that we will have to overcome. And I think we should not see this as a bane. We should not see this as a default setting that we have to fall into. We should try to look at this as an opportunity that has presented itself by chance, and see how we can blend our traditional ways and make the most of the digital world in the future and in the months to come. Now, one thing that all teachers that will be teaching, not just the next generation, but also perhaps the current generation, faces a huge challenge because of the fact that the internet throws open a very vast body of information. I hesitate to use the word knowledge, but a vast body of information to the students. And because the students have access to such vast body of information, it brings new challenges to the classroom. It very often can happen that the students, even singly, but most certainly when they are all put together, have more access to more information than the teacher can manage. And that becomes a huge challenge in a classroom. The other challenge is, of course, to use the internet in a manner that will help the learning outcomes, improve the learning outcomes, and so on. And like in the past, you did not have teachers who all did everything identically. So there's no reason to think that in the future, in the digital world, every teacher will be expected to do the same things everywhere. There will always be a local flavor. There will always be local challenges. There will be local limitations. There will be local solutions. Okay. So just like in the past, every class teacher had his or her classroom as a private domain where he or she could try out her ideas, try out her practices, and bring out the good out of the students. This will also happen in the future. It might happen in different ways from how it has happened in the past, but it will still continue to happen. The important point is that we as teachers learn to adapt to the new world, learn to adapt new ways, learn to adopt them to improve our teaching. And I'm sure that with this, if we live up to this challenge, we will be able to present to the next generation a different kind of teaching experience than what we ourselves have experienced when we were children. Now, there are a lot of buzzwords around. There's a lot of jargon that is floating around, no matter which sphere of professional activity you look into. But cutting across all the jargon, what is important is to realize is that teaching, learning has to be a holistic experience. The medium doesn't matter. Whether you use Google Classroom, or you use a Zoom, or you have a face-to-face interaction in the class, or whatever else you do. Teaching has to be a holistic experience. It is not like, you have a long list of check boxes. Okay, I ticked box A today, box B tomorrow, and when I reach Z, I'm done. It doesn't happen that way. You have to look at the whole process as a whole. Your theories of pedagogy, your ideas about what is right, what is wrong, has to blend very nicely into your teaching. You cannot say, oh, for the first few minutes, I'm going to do part A of my theory, and for the next 15, I'm going to do part C of my theory. It doesn't work that way. You have to blend it all very nicely. And this is possible with practice, with experience. And of course, in the new world, you will have to add a lot of new facets to your teaching. I'm sure all of you will rise to the challenge, and you will come up trumps and present a very different perspective on not just on science teaching, but a variety of other things to the next generation. Over to you, Neeraj. Neeraj, are you there?
Don't see Neeraja here.
Hari,
Okay,
yeah,
maybe
I think Hari, can
she
you?
got.
So,
Yes.
thank you, Bas, for the introductory remarks and inaugurating this session. Now over to Manish for for some words of wisdom on how creative learning, and then following which we'll have the webinar by Sir John. Manish.
Should I briefly introduce Manish?
Oh yes, please. Yes.
Yeah, I'll do that. Let me just switch on my video. Yeah, we are very happy to have Manish Jain here, as he's one of the speakers in this webinar, and we'll see more of him as the series progresses. Manish is an associate teaching professor in the Center for Creative Learning at IIT Gandhinagar. Of course, and before that, he has had a very long association with Sri Arvind Gupta, who is sort of the pioneer of hands-on and low-cost making science toys with low-cost material. And Manish has spent a long time with Gupta ji as well, and he's now innovating his own ways of teaching and learning science in a hands-on manner. His research interests, of course, lie in experiential pedagogy and STEM education. He's very well known amongst teachers through his work in this field. And we are very happy to have Manish, who believes that we need to add spice in learning and to make it more interesting for students. So thank you, Manish, for being here, and over to you. We are not able to hear you, Manish. Could you unmute?
Yeah.
Yes.
Thank you so much for having me here, Hari, Neerja, Apurva. I don't know if I can add words of magic. So Harinath, maybe that I don't know. But what I'll do here is, in the next few minutes, next 4-5 minutes, I will try to sort of share some of my experiences in this journey over the last. And I also see Bhakti here joining. Hi, Bhakti, and all the others who are joining from all across the country. Thank you so much for calling me here. Like they said, I can only talk about things that while this is a webinar and you guys are going to get certificates and so on and so forth, I don't know if I can give you any words of wisdom. I'll just show you something that I totally really believe in. I think teaching the next gen, in my opinion, frankly, is as it has become even more important, just like Bhas was saying, given that the medium has gone online. I think we will have to make sure that the content that we deliver and the way in which we deliver has to become engaging and inspiring. My name is Manish Jain. I come from, I'm speaking from IIT Gandhinagar, where right from the banks of Sabarmati, where we have this lab called Center for Creative Learning. Let me share my screen in a minute. Oh, host has disabled, that's okay. Where the goal is to make content which can engage and inspire. And I'll give you just one example, and then I'll move on to 3 things that I really want to communicate. You see, what I have in my hand is this small piece of a small square. And what I'm going to do is, take this square in front of the camera and make an arrow pointing up. And there is no trick that I'm going to play here. My hands are completely free. I'm going to show you maybe 1 or 2 magic, if you can sort of call it that, and if you want to call it that. So here is this arrow pointing up. I'm going to push it, hold it with my, left hand and push. And then, the backside shows up, and I will again mark it with an arrow pointing up. So that's all I've done. I will keep pushing, and you see the arrow keeps on pointing up, except now I will hold it with my other hand. This is completely symmetrical. I'm holding the 2 opposite corners. I will do like this, and you see what happens now. Hopefully you can see the arrow is now up and down. All right, very nice. And something magical has happened. And so I'll hold it with this hand. With this hand, what happens is up and up. With this hand, it is up and down. And now something more interesting is going to happen. I'm going to hold it with this hand now again, and you see what has happened now. It is now down and down. So I just have this, and there is nothing in my hands, completely empty, just a simple piece of square. It behaves in 3 different ways. It either points up all the time, up and down, or down and down, and only 3 possible combinations. Of course, the 4th one is symmetrical, and so that gets lost. But the reason I'm going to show, I showed you this activity was just. And I can talk about reflection, rotation, and symmetry and chirality, which is the left-handedness or the right-handedness that is going to come here. But I'm going to do this by doing something very interesting, which is engaging, which brings you back in the class. Look, the reason why this has become more important, the importance of making our content engaging, is because you are on the other side of the screen, like 200 and whatever number there is, and you can very easily in the webinar switch your buttons off and say, oh, bandwidth kharab. Sometimes I end up speaking Hindi, but there's no bandwidth. The connection is bad. It is raining very hard. We are locked down and so on and so forth. And the speaker has no option but to sort of believe you can't do anything about it. And so it has become even more important. It was always important while we were doing face-to-face to actually make sure our content is lying in 3, and this is what I want to communicate. In my opinion, our content has to be absolutely working in 3 different domains, and I'm going to maybe in next 2 minutes try to articulate that. One, we should try to see if we can break the subject boundaries. While I'm talking about something here and talking about symmetry and chirality, I can also bring in reflection along various axes. So while I'm talking about chemistry, which is what the focus might be, I need to talk about something else along with that. Like they say, make the boundaries porous. Like they say, when you dig deep down, when the miners dig down and they are deep down in the earth, they will also make some holes on the side to get oxygen from the side so that they don't. And similarly, we need to see if we are not restricting ourselves to just one boundary that we are going to talk about. So something that we do. Second, we are trying to see if we can make it engaging, almost like a story. You start here, you are here, and then we don't know where it will go. Almost like it is of course not possible all the time, but if we can try to narrate some stories which we can integrate as part of the the overall process that we're going to go through, that makes it very engaging and inspiring. And of course, in this domain, while there are all of these, I sincerely believe, while there are all these simulations that are happening, absolutely beautiful things that are there, that we can go on the internet and talk about, all these simulations that we talk about. But the most important thing, in my opinion, is going to be the teacher. And I think that brings me back to the single most important focus about the role of a teacher. And like Bhas was saying, it is not just to convey the ideas that I have in my mouth, through my mouth, into your head, but the role, is my opinion, is one of the biggest roles is to inspire. And I think that inspiration, if that can happen only with, the teacher being present and with the ability to engage and inspire. So I talked about how we have to make sure that we can make subject boundaries porous. Second, how we can sort of, weave it like a story. And third, give them something to relate to. And we have, and I'm going to show you this very interesting thing that we just made today. In fact, my colleagues, Neeraj and Janardhan just walked in and made this. We started this program called 30-30 STEM. And I'm just going to take 2 minutes and finish this. We started this program along with IISER. It is great to have Hari here, which comes on Sunday, every Sunday, 4 o'clock. And the goal is to bring you content which can, which is absolutely around something that are around you, which you can explore, and go deep inside to figure out the mysteries, beauty and magic of science and math that is around us. We called it 30-30 STEM for whatever reason. It doesn't matter. But then we thought can we create something very interesting which can show what the idea is? So this is just one object. And when I hold it in front of you like this, it is 30. I turn it the other way, you can see another 30, and I can turn it like this, and you should see STEM. So this is one object which says 30-30 STEM in a different manner. And at the back of my screen, you see 3030 written on a piece of paper. We did something similar with that. What we did was we wrote all that out, folded the paper in such a manner that in a single cut, all 4 letters 30-30 STEM actually came out. So that is I somehow see somebody else's screen.
Yeah.
You have to somehow
we request all participants to not share their screen.
And maybe you can disable people sharing screen.
Yes, I think we've done that.
But anyways, I'll go back because sometimes you get distracted. That's the reason we do it. Otherwise, it doesn't matter. So I was going to show you this, this object 30-30 STEM. And the reason I'm showing you is absolutely wonderful. When we do these kind of things, you see, it is visible from now. Actually, the background is not good. So yeah, you should see it here. This is 30. This is 30. And this is STEM. I hold it in 3 different ways, and I see all of these things. So the reason I'm telling you these things, or showing you these stories or the objects that we make in our lab, and I'm going to show you one more thing. Here is this this flower, which is an origami flower. One of my lab mates gave me on this Teachers' Day. But the object that I wanted to show you is this buckyball. It's a fullerene structure. It is 12 pentagons and 20 hexagons. We designed and created out of this, this laser cut wood, and the angles are cut in such a manner that it mimics exactly the dihedral angle of between pentagon and hexagon and hexagon and hexagon. And interestingly, I can make this in maybe about 30-35 minutes using only rubber bands, and I can then put something underneath it, and this becomes a lamp. And the reason I'm showing you all of this is, while I'm teaching fullerene chemistry, I'm going to take this lamp and have our class make something out of this. Or even when they're playing football, the structure of football is exactly same as the fullerene structure. And then I'm going to talk about whatever else that I'm going to talk about. So the third point that I was going to make was, we'll have to try to see if we can give something that we can relate to and our teachers can relate to. And with one small note, I will, end, Neerja. I think one of the most interesting things that is happening in our classrooms, or at least I used to feel, is that we will have to add, like Apurva was saying, we are serving a lot of khichdi in our classes, khichdi of curriculum. If for people who understand what khichdi is, for those, it's basically a mix of boiled rice and dal. And that is the curriculum that is interesting, absolutely required. But along with that curriculum, if we can add some spice, some tadka, some masala, some, whatever side dishes on the side in terms of the activities, games, and stories, and inspiring stories, I think that brings the engagement back. And that is something that we'll have to really, really focus on. And this pandemic, like Bhas was saying, has given us, put us, even in a, bigger, I would say, dire straits, in that sense that we'll have to, of course, spend a lot more time doing this. So hopefully with that, I was able to communicate the need to make our content engaging and inspiring. Tomorrow, Sunday, 4 o'clock, we will go again live on YouTube with our activity. And I was almost going to, and maybe you can see this tomorrow, but while we are talking about this digital medium, I'll just take this 1 minute to communicate. While it is very interesting interesting to say we need to innovate for our young generation. I think the most interesting, important thing, in my opinion, to keep in the mind is the attention span. Our kids today have very low attention span. You see, and that is something that we will have to bring in content which can have them sit on it for hours together. I mean, we'll have to sort of innovate on activities, games, or whatever. I mean, we just created this activity. We had 26 letters of A, B, C, D, E, and we did these holes in these letters, 0 and 1. And, it takes us about 10 minutes to sort these cards out. But with just a stick and putting these holes in 5 holes, I can do it in 5 seconds. And that, if I do, I leave this challenge with my students, with my children, saying, look, how did this work? And this is exactly how a computer would work. This is how a computer would solve a problem. And that is the reason for understanding these computational thinking or skills like that. So teaching the next generation, in my opinion, one of the things that we'll have to sort of focus on is to see how we can get that attention span of 3 seconds. If we can make it to 20, 25, whatever, I think that will be great. So with that, I will stop. Thank you so much for having me here, Bhas, Nirja, Apurva. And I just realized by looking at, this is the first time I'm seeing Sir John Holman. I did not know that he was the first director of stem.org.uk. I'm a big fan. For those who don't know, maybe they should go visit stem.org.uk. It's a brilliant collection of activities. I mean, my journey into this thing started about 8-10 years ago. Before I moved to Pune with Abhinji, I was just a simple chip designer in the US. And I started viewing this website, stem.org.uk. Absolutely brilliant collection. Good thing is free, wonderful resources. We should take advantage of that. Thank you so much.
Thank you. Thank you, Manish. So I'm sure that we will all encourage teachers, and the teachers are with us to make the teaching and learning much more interactive and interesting, as you said. With that, let us move on to the most awaited segment of today. It is our pleasure to introduce the speaker, Sir John Holman. Sir John Holman is Emeritus Professor of Chemistry at the University of York and the President of the Association of Science Education. He's a Senior Advisor in Education at the Gatsby Foundation and Founding Director of the National STEM Learning Center and past President of Royal Society of Chemistry. His notable honors include the Royal Society's biennial Cowley Education Medal, which is given in recognition of his significant impact on science education within the UK. Sir John was knighted in 2010 New Year's honors. In 2014, the Royal Society of Chemistry awarded him with the Lord Lewis Prize in recognition of his extensive influence on chemistry education policy. He was named as one of the UK's 100 leading practicing scientists by the Science Council in 2014. We are in fact honored to have you here, sir. Today, Sir John is going to share his experience of what works best in science teaching. So now I request Sir John to start his webinar.
Thank you, Niraja, and good morning, everyone. I'm in England. I'm in York. It's 12 noon, so I can just say good morning. And it's an enormous pleasure to be talking to friends and colleagues in India. Thank you to the Royal Society of Chemistry for arranging this, and for the Institute in Pune for arranging this session. And thank you, Professor Bas, for your introductory words, and Professor Manish for your very interesting words just now. And I love the demonstration with the arrows, which I shall make quite sure that I use next time I'm talking to an audience of students. In the UK at the moment, we have the same problem with the pandemic that you have in India. We have our schools have now returned, having been closed for 6 months. So that is an enormous impact that's going to have. Our schools and universities have been closed for 6 months, but they are back now. This is essential, because the next generation is what we all depend on. There is nothing more important than young people being educated, and particularly in science. So I'm going to start sharing my screen now so I can tell you a little bit about the presentation that I'm going to make. And Niraja, can you just confirm that that you can see my presentation in slideshow mode?
Yes, we can.
Good, good. Thank you very much. Now, in preparation for this talk, Niraja and colleagues have collected quite a few questions from you, from the people who were going to come and attend this lecture. I'm going to leave nearly half of the time for discussion of your questions. So please do make sure you send your questions in. These are some of the ones that were sent ahead of the talk. So let's use that for my beginning. One of the questions was, what qualities are required to be a good science teacher? And in this talk, I hope I'm going to share with you some of the ideas about what makes good science teaching. And then another question, how can we make science classes enjoyable for teachers and students both? And of course, the answer to the second question depends on the first. If we can be good, stimulating teachers, then our students will enjoy it, and so will we, because as science teachers, we get professional satisfaction when we do our job well. So here is the outline of my talk. I'm going to say a little bit at the beginning about the career that I've had, because it's not because it's particularly interesting, but because I've been a chemistry teacher all the way through it. I'm then going to share with you some research about recommendations for what makes the very best things in science teaching. I'm then going to focus specifically on one of them, and that is practical work in science teaching. And then, as I've said, I want to leave a lot of time for questions and discussion. So, moving on first to my career as a chemistry teacher. I started off by studying chemistry at the University of Cambridge, and then I became a teacher in secondary schools in England. I taught in many different secondary schools. I taught chemistry and also biology and some physics. And then for 10 years, in 1984 to 1994, I was part-time a teacher of chemistry and part-time writing textbooks and science curricula. And I wrote the national curriculum for science in England. Then in 1994, I became a school principal, but I was very keen to continue teaching chemistry. So I was a chemistry teacher and a school principal. Then I became professor of chemical education at the University of York. And it was my great privilege to start teaching chemistry to undergraduates. So I have taught chemistry to undergraduates as well as to high school students. Then I became director of the National STEM Learning Centre and the government's advisor on STEM. And I continued to teach chemistry at the University of York. In 2010, I retired from the University of York, but became an advisor to educational charities, including the Gatsby Foundation. And I continued to teach chemistry until 2017. So I can proudly claim that I've taught chemistry for 50 years. Then I became, as you've heard, the president of the Royal Society of Chemistry and I'm now the president of the Association for Science Education. So you can see that I've stayed close to chemistry and the teaching of chemistry all my career. And I can tell you I've had enormous pleasure from it. Now, one more of the questions that came from you in advance of this lecture was, what is your most remarkable teaching experience? I'm going to answer that question twice. But the first one, I'm going to tell you about experience I had here in India. Because in 2017, as president of the Royal Society of Chemistry, I visited India and went to a number of centres. For example, I met two leading industrialists, Indian industrialists, who I knew from past acquaintance, and Anand Mahindra and Yusuf Hamid. Yusuf Hamid, of course, has the wonderful pharmaceutical production company Cipla. But as well as meeting captains of industry like that, I had the great pleasure of visiting schools here in India. I visited the Atomic Energy Center school in Mumbai and the Shishuvan school also in Mumbai. And that was one of my greatest experiences in the teaching of chemistry, because when I went to the Atomic Energy School, the teacher asked me to teach a lesson. Slightly took me by surprise, but I was glad to take up the challenge. And so I spent, well, he said, would you teach my class for 20 minutes? And I said, yes, certainly. I ended up teaching them for an hour. And I can tell you that this was the most motivated, enthusiastic, and bright class that I have taught anywhere. So that was one of my greatest teaching experiences. And one of the things I did was talk to them about balancing chemical equations. And I can promise you that when I left the school 3 hours later, I still had students coming up to me and saying, please, will you give us another test with a chemistry equation? Please give us another chemistry equation to balance. The enthusiasm was wonderful. What wonderful students they were. So there we are. That's the answer to one answer to my greatest teaching experience. Now, I want to tell you a little about my class of undergraduates at the University of York. So every year until 2017, I taught chemistry and biochemistry at the University of York. And every year, I gave them the same questionnaire. And it was, here's the questionnaire. How important were each of these in influencing you to study chemistry at university? And there we are. You can see the options that I gave them. Was it the labs? Was it the parents? Was it your teacher? Was it your friends? Was it your exam grades? Here are the scores in 2016. 5 means that it was very important. And there is the answer for 2016, 3.96 for your chemistry teacher. And every year that I have administered that test, and I've done it, I did it for 17 years, every year the top score was the chemistry teacher. This is how important teachers are. And this will continue, I predict, to be the case well beyond the period of the lockdown and well beyond the period of the impact of digital technology, because teaching is essentially an interaction between human beings, and human beings respond strongly to one another. So don't let's underestimate the absolutely vital importance of the chemistry teacher. Now, I want now to tell you about some research on recommendations for secondary science teachers. And this is taken from a report that I co-authored for the Education Endowment Foundation, which is a big educational charity here in the UK. I co-authored this 2 years ago. And it has collected together all the best research evidence for secondary science teaching, and we pulled out 7 broad areas of recommendations. I want to share some of them with you, because if you can be your best as a teacher, yet then that is the transformative thing that will happen in your science teaching. You can access the report here in India, and I do recommend it to you. And the approach that we took was to be evidence-based. So we looked at the research evidence around science teaching that have been published in the best journals, and we looked at the quality of the evidence and the quantity. And that is where these recommendations come from. Why is that a good thing to do? Because it helps teachers to make more informed decisions about what to do, but also what not to do. Because there are some recommendations I'm going to be telling you that will be pointers at what you should prioritize. But I'm not diminishing the importance of teachers' own experience and expertise. We will have some teachers attending this lecture who've been teaching for decades of years. You have huge experience, and I'm not saying that what I have to say today should change what you do, but it will supplement it. And I think you'll find it'll confirm a lot of what you know already. Here's another question that was posed before this lecture. Should science teaching be done scientifically, following the process of science to teach science? How? Well, here's my answer to that question. It should be done scientifically, and the evidence I'm going to put in front of you is scientific. It's from the social sciences, from educational research. Let me tell you about the method by which we carried out this study. First of all, we looked at all the research evidence about science teaching, and we identified 7 areas where we felt that the evidence was strongest. And then in each of those 7 areas, we commissioned evidence reviews looking in detail at what the research literature says. And the University of Oxford was very important in helping us to do those reviews. And then from those reviews, we pulled out the parts that we felt could make the most difference to teaching. And now here's the important part. We wrote this up in accessible language, because the problem with educational research, like much specialist research, the language can be quite difficult to penetrate. So we wrote it up in accessible language. We then consulted teacher panels, and we then checked to make sure that it makes sense in today's classrooms. Peer review and publication. And there's the panel of expert advisors who are a mixture of university specialists and school teachers. So out of this come our 7 recommendations. I'm not going to go through all 7 of them, you'll be pleased to hear, but I'm going to pick out some of them. But here are the 7. The first is about preconceptions, building on the ideas that pupils bring to lessons. The second is called self-regulation, and this is about helping pupils to direct their own learning. Then about modeling. As science teachers, we use models all the time, and all kinds of models. And what we're saying is it's important that we use them consciously and to best effect. Science teaching cannot be done without knowledge, and that means memory. And it's valuable for science teachers to understand better about how memory works and how it can best be exploited. Practical work is the essence of science teaching, and I'm going to make a separate topic to focus on about practical work. Then language of science. Science has its own special vocabulary, and it's very important that we use it consciously. And then finally, feedback, which has been shown to be the most powerful single change that teachers can make, giving structured feedback to improve, help pupils to move on their thinking. In red there, you see the 4 areas that I'm just going to say a little bit more about in this presentation. So the first area that I want to say something about is about preconceptions. The idea that we should know what the pupils bring to their lessons and then build on them. Because everyone, students and adults, will have ideas before you start teaching them. And sometimes these ideas may be naive, they may be simplistic, but they're not exactly wrong. Sometimes they're plain wrong. If they're wrong, we call them misconceptions. But the important thing is you do need to understand the preconceptions that people bring with them when they come into the classroom. And if you think about it, this notion of building on preconceptions is fundamental to the history of science. If you think about how science has evolved, it has always involved building on the conceptions that we started with. Isaac Newton said, "If I have seen further than others, it is because I have stood on the shoulders of giants." That is what scientists do. The theory of relativity built on the Newtonian physics that Newton had built before. So there's nothing to be ashamed of here, that people come with preconceptions. But the important thing that the teacher should do is to understand the preconceptions that pupils come with And teachers can do that by tests, by discussion, and by there are some excellent assessment banks from, for example, the American Association for the Advancement of Science. If you look in the publication, you'll see some very good ideas there. And then, having identified the preconceptions, the idea is to help pupils to move on from those preconceptions, and cognitive conflict is an excellent way of doing this. And Manish, I loved the experiment with arrows because that was a classic example of cognitive conflict. What a wonderful thing to look at something and say, my, that's strange. Why did that happen? That's cognitive conflict. And good teachers can always use that, wow, that's strange moment to help move on pupils' thinking. Just one example, when teaching about solids, liquids and gas, students often think that gases have, between the particles, they have something else. Of course, we know that gases consist of particles in a vacuum. Most students come thinking that there is something in between the particles, whether it's air or ether or bacteria or something like that. The fact that there is space between particles and there's nothing in it is a classic conceptual move that needs to be made. And you can move them on by cognitive conflict, by showing young people that gases are compressible. So there can't be anything in between the particles. Just one example of cognitive conflict. Now I want to move on to just say a little bit about modeling, which is such a fundamental part of teaching science. Scientists use models all the time. Perhaps if you're a chemistry teacher, you may think, when I use the word model, you may think about a molecular model. But there are many other kinds of models. We use pictures. Every time we draw a diagram, we are making a model of a situation. It's not the real thing. We use mathematical models all the time. And of course, the classic mathematical model in chemistry is a chemical formula. That's a mathematical model for the molecule. We use graphs and diagrams all the time. And of course, increasingly, we use computer models. But the important thing is that pupils need to understand that these are models of the real thing, but they are not the real thing. And it is quite easy to form the impression that what you're looking at is the real thing. And research shows that there are broadly 3 levels of conception about models. The beginner level, for a young child, they cannot see the difference between the model and the reality. An intermediate understanding is that the young person can see, yes, this isn't the real thing that I'm looking at. It is a model and it's different from the real thing. And then the advanced expert understanding of models recognizes that there are several models for every situation. There isn't any one correct model for any situation. If you think about teaching about electric current, teachers often use the analogy of water flowing around a circuit of pipes. That is an analogy for electric current. But it's an imperfect analogy because, of course, electrons in an electric circuit are moving backwards and forwards all the time. So there are other models, the rope model, the delivery van model, which can be used. And an expert user of models can understand the difference between these models, and they can use whichever model seems appropriate for the time. And of course, the wave particle duality is a classic example of models that can be chosen depending on the job we want them to do. So what the summary of the message about modeling is: be aware that you are using models and that models are powerful, but that we need to understand when we're using them. Now, the next area that I want to briefly just touch on is about memory. You cannot do science teaching without learning. I'm not saying that everything should be about rote learning, but understanding how memory works is a very powerful tool for teachers. And in the book, we use that very simplified model. Of course, the reality of memory is much more sophisticated than that. But this is a useful model for teachers to keep in mind, the idea of working memory and long-term memory. And the neuroscience shows that the working memory is limited. Working memory is where you do your thinking. As you process my words, you are doing that in your working memory. And then you will turn some of that into your long-term memory, and it will stay there. And then later on, when you need it, you would retrieve it from your long-term memory. So the important thing to understand as teachers is that the working memory is limited. It really is very limited, the amount that we can hold in our memory at any one time. And what teachers do is to help young people to move from their working memory to their long-term memory. And there are many ways that teachers can do that. For example, retrieval practice. Every now and then, and the research suggests a week is about the optimum amount of time, every now and then give young people practice at retrieving knowledge from their long-term memory. Of course, the classic way of doing that is to give them a test or to encourage them to elaborate on their long-term memory. Don't just say, how does an electric motor work? Ask them to elaborate it by saying, why does the electric motor turn faster when the current is higher? That's elaboration, a powerful tool for rehearsing long-term memory. Now, before I finish, I want to say some more about another part of this work, which I think is exceptionally important, and that is practical work. Practical work is the essence of science teaching, and of course, experimentation is the essence of science. And that's why I want to develop this area a little bit more in this talk. And it is an area that I have been fascinated in for many years. I realize that with the pandemic, it is harder to do practical work. And I also realize that some schools in countries around the world have very good labs, others don't have such good labs. And I've seen very good laboratories in schools in India, and I've seen more basic laboratories. So I do recognize that it's difficult to reach perfection. But what I want to tell you about is a report that I wrote in 2017 for the Gatsby Foundation called Good Practical Science. And this report is our attempt to identify what practical work in science looks like when it's world class. So we went to 6 countries around the world: Netherlands, Massachusetts, Germany, Finland, Singapore, and Victoria in Australia. Why did we choose those countries? Because those administrations have been shown through international tests to do very well in science, but also we knew from the research evidence that there were interesting things to see in the 6 countries we visited. So we visited over 20 schools, we met teachers, hundreds of pupils, we met government officials, and we immersed ourselves in a study of what makes good practical science. And it was quite clear, remember this was in 2017, pre-pandemic, but it was quite clear then that practical science is alive and flourishing and valued highly by professional scientists. Now, so if you talk to professional scientists, and I'm sure those who are here in this lecture today will agree, and certainly the Royal Society of Chemistry agrees, that practical work is an essential part of science education. And the great thing is that that's not just coming from professional scientists. It's coming from teachers, from their experiences, and most importantly, from students. Students like practical work. In 2016, the Wellcome Trust carried out a survey of students, 15-year-old students, and they surveyed 4,000 in a very rigorous survey called the Science Education Tracker. And they asked them the factors that engage them best with science. And the factors that pupils rated most highly, first of all, having a good teacher. We know that. We all know that already. But secondly, enjoying practical work. And both of these were rated at the highest possible rating by 35% of the pupils. So in other words, practical work is up there with good teaching as what makes the biggest difference. Young people love practical work. Now, one of the strongest points that we make in our report, and something that we saw carried out very well all over the world in the countries that we visited, is that you need to be clear why you are doing practical science. So we need to have a clear understanding of the purposes of practical science. Why do we do experiments? It costs money, we need laboratories, we need chemicals, it takes time, we have to be careful about health and safety. So why do we go to all this trouble? And in our international survey, we identified 5 purposes of practical science. The first one, and when I say we identified them, this was by talking to teachers, looking at official policy documents, and talking to experts. What do they think the purposes of practical science are? The first one, to teach the principles of scientific inquiry. Science has a particular way of finding out the truth about the world, and it involves the experimental method. And teaching that can be very well done through pupils doing experiments themselves. The second purpose is that when you do experiments, you improve your understanding of theory through the practical experience. Seeing is believing. And we heard that again and again from young people and from teachers. The third purpose is to teach particular practical skills, such as measurement, observation. In chemistry, when you do a titration, you are learning not only about acids and alkalis, but about precision and how to make accurate measurements. And these skills will be useful in future study or employment. The fourth reason, and I've touched on this already, practical work is highly motivating and highly engaging. And if you talk to people who come to university, they will often say, where I got turned on to science was by doing experiments. And then the fifth and final area of purpose is that doing experiments enables you to develop higher level skills. Let's take teamwork as an example. When you do an experiment, often in schools, you work in teams, and having that team experience is part of building up that skill, which will be a wider skill in future life. And perseverance. Experiments don't always go well. By repeating experiments, we teach the importance of perseverance, keep trying and trying and trying, and that will be a skill in later life. So from this work, from this study, we have developed 10 benchmarks for good practical science. You can find them in the report. The report's called Good Practical Science from the Gatsby Foundation. And here are the 10 benchmarks. And the first 2 are about planning and purpose. That was the point I was just making. When doing an experiment, it's very important for teachers to understand why you are doing it. And it could be for one or more of those 5 purposes. But there isn't another point in doing an experiment unless you know why you're doing it. The third benchmark is about the expertise of teachers. And this is where specialist qualifications are very important, because teachers who have expertise will do practical work more confidently. Fourth is about frequency of practical science. I'll say something about that in a minute. Laboratory facilities, obviously. Technical support. In England, we're very fortunate in having technicians to help support practical work, and they are invaluable. The 7th benchmark is about computer simulations. This is so important in the current pandemic. What we found is that in the best countries, the countries where they do best in science, they use computers to enhance real experiments, but not to replace them. Now, I know in the situation of the pandemic, sometimes we have to replace the experiments, but the best way to use computers in teaching is to supplement the real thing, but not to replace the real thing. There's no substitute for the real thing. The 8th is about investigative projects, more about that in a second. The 9th is about safety and having a balanced approach to risk and not allowing dangerous practice to happen, but also not allowing risk aversion to stop practical work. And then the 10th one is assessment fit for purpose. So there are 10 benchmarks for good practical science based on world-class practice. And I encourage you to look at the report. Now I'm coming towards the close of the formal part of my talk, and I'm very much looking forward to your questions. So I hope you're sending in your questions. I know that Niraja and colleagues will be looking at the questions as they come in, and we'll be pulling out some of the frequent questions, and I'll answer those or try to and discuss them shortly. But here's one more question that came from you before this lecture started. How much should a science teacher teach in the class versus experiment with students in the lab? How frequent should science experiments be, hands-on experiments? Very important question. When we did our international study, we decided that on balance, in the best schools in the best countries, they were doing some kind of experiment in about half of the lessons. Now you might say, well, that's impossible. But I would emphasize that I said some kind of experiment. So these might be demonstrations. They might be very quick experiments. So at the beginning, in that wonderful demonstration that Manish did for us, that was a very quick demonstration, but my goodness, it got us thinking. And that in the best schools, there is something experimental happening in about half of the lessons. And it may just be very quick and it may be a demonstration, but it's in about half of the time. One other, and this is the last of your pre-questions that I'm going to talk about, and it's going back to a question I asked right at the beginning. What is your most remarkable teaching experience? Well, I can tell you that one of them was when I taught students in the Atomic Energy Center School in Mumbai. But another one was teaching practical projects at Watford Grammar School, which is where I was head of chemistry for many years. And we would give students an opportunity to do their own practical project work. And we would give them about 3 weeks to do their own project. So they would decide their own project and they would carry it out experimentally. And so the remarkable thing about this was that it was an extended investigative project. The students took something that they were interested in and they investigated it. And some of the best work that I have ever seen has happened when students carry out their own project. I saw several students carry out work that was easily undergraduate level, because they had been given the opportunity to follow what they were interested in. They'd be given the time to do it. Some of it, I would hasten to say, I would risk saying, was actually veering on the edge of PhD work. Young people are capable of fantastic work, and I've seen what fantastic young people you have in India. You just need to give them a chance, and giving them a project to do is one way. So there we are. I've finished the end of my presentation, and now I'm very much looking forward to hearing the questions that you have to discuss.
Thank you, Sir John, for your guiding words. And I'm sure that everyone really enjoyed listening to your experiences of teaching chemistry for 50 years. That's a long time. We have a question from Ms. Rita Sarkar, and the question is, what is the biggest challenge you faced as a teacher?
I think the biggest challenge is how to give everyone an equal experience of science when you know that some of your students come from poorer homes than others. So in England, we have a big gap between the most privileged and the least privileged. And I know you have similar gaps in India to what we have in England. And that was true in the schools that I've taught in. Some of the students would come from families with graduates in the family, families where they would talk about science, there would be books in the home. And other students would come from a home where there are no books, maybe there's only one parent in the family. There is no knowledge of science in the family. And the biggest challenge in teaching is giving the second, less privileged young people the same chances as the first group who are already so privileged. That's the biggest challenge.
I think Apurva can take the next question. Apurva?
Yes, sure. I'm happy to do that. Thank you very much, Sir John. I'm going to ask some of the questions on behalf of our participants. Madhavi, Kanchi, Priyanka Ghosh, and Sandeep Desai have all asked questions which are of a similar nature. And you have emphasized a lot, Sir John, on the practical experience of doing science, and their questions pertains to the same issue. They ask, how can we do experiments virtually, as many solutions may not be available at home, or if laboratory facilities, I mean, this is specifically in the pandemic situation, and also in case laboratory facilities are not available in their schools. So I think there are two angles to this question. One, if lab facilities are not available, how can we do experiments? And the second is, if we are doing an online mode of education, what can we do about the experimental work? Okay.
So the first part, there are some wonderful practical chemistry experiences available online. And I would urge you to go to the Royal Society of Chemistry. The website is called Learn Chemistry, and you will find some excellent online experiences there. And they include simulations. And of course, another way you can get chemistry online is through videos of real experiments on YouTube. And this is important during the pandemic. The Royal Society of Chemistry can show you the best, but it is still no substitute. Now, I want to tell you about another piece of research that has recently been published that looked at the difference between a teacher demonstration and a video. Now, as we come out of lockdown and young people go back into school, it will be harder to do full class experiments where every pupil puts their hands on the equipment. That's going to be harder to do. We know it is. It's already happening in our schools because of social distancing. The experiment that we carried out was to take 3 groups of students. One group did an experiment hands-on themselves. Another group watched a teacher demonstration. And the third group watched a video of the experiment. And then each of those groups was given a test of their understanding of the experiment. So it was a test about the experiment. It might have been about the safety precautions or about the conditions in which it was carried out. The result was that the group who did the experiment themselves and the group that saw the teacher demonstration scored the same, approximately the same. The group that watched the video scored much, much lower. Now, what does this tell me? And why did it happen? The experimenters believe that when the teacher was doing the demonstration, he or she was talking about the experiment and asking questions about the experiment while they carried it out. And that was what was making the difference. It was the getting the cognitive activity going on amongst the students while she was doing the experiment. Now, I think there's something to learn there about the online world as well. If a teacher can stimulate the people who are watching the demonstration with questions, even though they're not in front of the class, that is still much, much more powerful than simply watching a video.
Thank you so much. So interactivity and engaging with the students seems to be the key. Thank you. Neeraja, the next
Yes.
question.
Yes, so a lot of questions have come, especially with respect to chemistry, since you being a chemist, but many of them have to do with the subject being termed as a memorization subject, wherein students feel chemistry is all about remembering equations and remembering the reactions and products of a particular equation. Shamla Sundar wants to ask that how do we make students understand that chemistry is beyond something more than just remembering, and if we at all have to make them learn equations, what is the best way to make them memorize the equations?
Okay, I'll do the second part first. What's the best way to help them understand equations? I go back to what I was saying about memory. Use retrieval practice. So if you've taught them about how to balance an equation, don't just forget about it. Keep giving them practice and get them to elaborate. Give them more challenging equations, successively more challenging equations. So think about the model of memory, working memory, and the long-term memory, and apply that model of memory to teaching about equations. Now, the first part of the question was about how do we show that chemistry is not just about memorization. I'm a big advocate of showing the context of chemistry. In fact, I wrote a book called Chemistry in Context. And the reason I called the book that was that my co-author and I wanted to show the ways that chemistry is used as well as the facts of chemistry. And we know that chemistry is everywhere. Chemistry is in food, chemistry is in our environmental protection, chemistry is in our paints and our plastics and our fibers. If you keep reminding young people and giving them examples of how chemistry is used in the real world, then you will constantly be showing them that it isn't just about memorization of facts. You do need to have some facts. You can't do chemistry without facts, but they're facts for a purpose. And those facts are to apply chemistry. And we can all think of many ways that chemistry makes the world a better place. As we speak, chemists are actively at work finding better ways to make the vaccine that's going to get us all out of this pandemic. It's chemists. So try and show the context of chemistry. That'll soon tell them it's not just about memorization.
Yes, that really is interesting way to get students to recognize chemistry all around us. Definitely playing the context in front of them really helps. Apurva, do you have the next question ready?
Yes, sure. I'm again going to club 2 or 3 questions so that we are able to accommodate more questions from people. We have questions regarding a slightly different aspect than content or the conceptual aspects of education. It's about inclusivity, which Sir John also referred to in his talk. 2 or 3 questions about inclusivity is how to maintain inclusiveness in a class with diverse conditions and how to keep interests, retain interests of students. This was asked quickly. We have also somebody from HMV English High School asking that they have 80 to 90% privileged science students, and how does one deal with this kind of a situation. And another question by Priyanka Ghosh, which is specifically about how to make science teaching enjoyable for differently abled students. So it's very
Yes.
nice that people have been thinking about inclusivity.
Yeah, thank you. Yes, that's quite a lot of questions there. Let me begin with inclusivity. I think it's very important. Well, first of all, it is vital to be inclusive. Chemistry opens our minds to the world. Someone who understands chemistry has a way of looking at the world that is empowering, and we don't want to deny that empowerment to anyone. And I believe chemistry can be taught to everyone. But we have to think carefully about inclusivity and about how for some people that will be harder than for others. And if we think about general academic ability, I come back to what I said at the beginning about preconceptions. If we are going to include those who are the slower learners, as well as those who are the brilliant youngsters who learn everything very quickly, we need to understand what the starting point of our young people is. And that means understanding the knowledge that they come into the classroom. And some of them will come into the classroom, say we're talking about the atomic theory, we're teaching the atomic theory. Some of them will have learnt about this from books that they've read, or talking to their parents, or talking to their sister, or looking at the television. Some of them will come in with quite sophisticated ideas, and some will not. And it's so important that teachers understand what the starting point is for young people. And then we have the question, if we know that some young people have a very high understanding and some have a lower one, how do you deal with that problem? And there's a big question about whether we have mixed ability teaching, in which we put people of all abilities into the same class, or whether we put them into sets with some, top set, middle set, bottom set, that kind of thing. And the evidence is quite mixed, but certainly when I have been to Finland, which is one of the most highly achieving educational countries in the world, they are very keen on putting students of all abilities together. In fact, in Finland, when they design teaching groups, they make sure that each teaching group has people of all levels of ability, so that the high ability students can help the lower ability students who need more time to understand the topic. So mixed ability teaching can be very helpful towards inclusivity. And certainly by putting people of different abilities together, you avoid stigmatizing those who are of a lower academic ability, because if you set them apart, you're telling them something about themselves. Now, that was one aspect of inclusivity. The other aspect of inclusivity is about physical disabilities, sensory disabilities. I have seen in my career some wonderful examples of how, by thinking carefully about young people's abilities, you can teach science very effectively to people with quite profound sensory or physical disabilities, as long as you are sensitive to what their needs are. And that's another thing that the best schools around the world have done.
Thank you so much. Neeraja, do you have the next question? How
Yes.
many questions do we have time for?
I think we will take this last question and then we can proceed to next week's webinar coming Saturday, that is on the 19th September. I request everyone to subscribe to the YouTube channel so that you get updated about the webinar that is upcoming. Okay, let's move on to our last question. And this is a question by Abu Tahla. The question is, for those who have a fear of the subjects of mathematics and science, so we always see students who are afraid to learn science or mathematics. What are some ways that you feel will inspire them to, to get over this fear and start learning these subjects in a nice light?
I think I'm very familiar with that issue, because particularly teaching chemistry at the University of York, some of the students who come to the University of York don't have advanced level mathematics, and so some of them are quite frightened. And I used to teach thermodynamics, and you really do need mathematics there. I think the key is to try and focus not on what they're frightened of, but what they love. And I think there is hardly anyone who does not love some aspect of science. So if we take chemistry, for example, I know that quite a lot of students do find the mathematical aspects of it difficult. But ask them, what do you love about chemistry? And this is something that I have done with undergraduates. Often they'll tell you it's something to do with experimental work. Try and find the things that they love. And it might also be about what I was talking about, context before. They may say, we love it when you tell us about the ways that chemistry can be used. So do try to focus on the things they love, as well as the things that they're frightened of. And if this is with a chemistry class, why not give them a little questionnaire at the beginning of the year? What are the things that you love about chemistry? And then you might ask them, are there any things that you're frightened of? But focus on what they love before you worry about the things that they hate.
Definitely. I think that will inspire a lot of students to get over that the fear of subject and really start learning the subject and loving it. Thank you, Sir John, for your guiding words. I'm sure that all the teachers, so we are able to see the chat box, and the chat box is flooding with a lot of teachers thanking you for sharing your experience and inspiring them to teach better. To really give the vote of thanks, we have Mr. Ajit Sharma from RSC. He's the General Manager, India. Ajit, could you please take over and express our vote of thanks?
I've allowed him to unmute.
Yeah, just 1 second, Ajit.
Yeah, you can now unmute yourself. Yeah, yes.
Am I audible now?
Yes, you are. Yes.
Brilliant. All right. Good afternoon, everyone. I'm Ajit Sharma, Country Manager for Royal Society of Chemistry for India and South Asian region. The arduous task of giving the vote of thanks to such an august gathering of people. Rather than saying people, it is the gathering where everybody is an education expert. But the most encouraging fact here, in my opinion, is everyone is a teacher, but yet very, very eager to learn further. And it's events like these which gives you confidence, which gives you a belief that as long as the spirit of learning excellence is alive, we will continue to grow to the new heights. Also remarkable is the openness of moving from the conventional transmittive method of education to the experiential learning. And I was very thrilled to see how Manish and then Sir John Holman and then, we built on the need of the experiential learning and how the engagement plays a critical role, how teacher differentiates between everything else from the fact to the reality. So I'm sure that we can take home some critical points over the today and some remaining 11 episodes. So a big thank you to all the educators around the country who have joined us today. When you go back today, please spread the word, ask your friends to be a part of this great initiative in great numbers and take advantage of the speaker lineup that the magnificent team of IISER Pune has put together. This is really a once in a lifetime kind of an opportunity. It's indeed a great pleasure and it's a marvelous opportunity to hear Sir John live and face to face. So thank you very much for taking time out. It's a weekend. We are really, really grateful that you could spare some time for us and enlighten the audience with your immense experience in general and what makes science teaching interesting in particular. I think you're an institution in yourself and anything coming out from you is a lesson for everyone who's in the audience. Thank you very much.
Well, can I just say thank you. This pandemic is a terrible thing, but one good thing is I don't expect we would have had this session had it not been for the pandemic. So it's given me the opportunity to interact with so many enthusiastic and wise teachers around India, and I've enjoyed the experience very much. Thank you.
Thank you, Sir John. Professor Hari, our dear friend, guide, and also a conceptualizer of this entire webinar series. Thank you so much, Hari, for making us a partner in this great initiative, which shall help teachers across India in many ways. I keep always, all the engagements that I have with you, I always keep my eyes and ears open to learn from you, and I think this has been another great learning opportunity. Thank you. Professor Bapat, Dean Academics, for sharing your vision behind the webinar series. It is the vision which helps and guides. So, to guide this entire thing effectively. So thank you very much for that. And Manish, what should I say? You should have, I was watching the YouTube feedbacks and the online chat sessions, and I tried to capture some of them, and then I just gave up because there was simply so much of, you just immediately connected and gave a very nice emotional connect with the audience. And I think that's what experiential learning is all about. And you presented a brilliant example. So thank you very much for sparing your time again. Really appreciate that. Dr. Nirja, Senior Technical Officer, IISER Pune, and Dr. Apurva Barve, I think this could not have been possible without your kind help and support, right from conceptualizing to the delivery. This has been a great start of this event, and I'm looking forward. I generally try and avoid the webinar series because they tend to get very transmittive. But what I've learned today, I think I will be attending all the remaining 11 ones so that I also learn and grow with part of the this thing, the initiative. Dr. Manjula Rao, our former colleague at the British Council and an expert in Indian education system, really, really appreciate your guidance. We really, understand your commitment, and we really thank you for that. And in the last but not the least, I would thank Rajesh Parishwad, our leader in external relations and public policy, Bhakti, for being the firm bridge between the aspirations and the delivery of this great exercise. And I'm aware that these fantastic, flawless events are never possible without the absolute commitment and pure dedication of the great team of this great premier institute, IISER Pune. You guys are doing a fabulous, great job in nation building via education and talent development. So keep that flag flying very, very high. Thank you very much. So besides this event, as a citizen also, I'm very, very grateful for all the help that you provide. Thank you so much. Over to you, Nirja.
Thank you, Ajit. So with that, let us conclude today's webinar. Just a couple of announcements. You don't need to re-register for the next webinar. You only need to register for the webinar series once, and you will get all the details of the upcoming webinars in your email that you have shared with us. And also, if you subscribe to the YouTube channel, you will be seeing the upcoming webinars there as well. We are getting a lot of questions regarding how the exam is going to be. As teachers, I think that is not something we need to be afraid about. We promise it will be an easy exam. As long as you're with us and you share your experiences and your comments, we are very happy. That is the aim of this webinar series, is to really create a cohort of teachers that share best practices in education. So I assure you that the exam will be an easy exam that you can take from your home. With that, I thank everyone from the speakers to the participants for joining us today. See you all next Saturday. Do keep a lookout in your emails for the updates from us. Thank you.
Thank you. Thank you so much.
Thank you.